Hello student, I am Prajjul Deswal, pursuing master from IIT Bombay. In that college, I am also teaching assistant working with top class professor of our country. So here I would like to teach physics and mathematics from class 6th to 12th standard. I have experience of more than 2 years in online teaching, and I completed my BTech from Tripaliti Jabalpur, and in in class 12 CBSE 2013 I scored 96% in physics, chemistry and math combined. Okay, thank you. I would like to give you demo.
So let's begin. So there is a question that is said horizontal force of 10 Newton is necessary to just hold a block stationary against a wall. The coefficient of friction between the block and the wall is zero point 0.2. The weight of the block is, you need to find the weight of the block. I will tell you that what is given in the figure, which actually this one is given in the figure itself. Okay, so you see. Okay, so this is the figure it is given. It is acting in the center of the point, that is here. So this is given figure. So now you need to solve. Okay, so a horizontal force of 10 Newton is just necessary to just hold a stationary box. So I will tell you this two concept that is needed. The first one is frictional force, that is resisting resisting relative motion. Okay, you always remember that it's about relative motion. So resisting relative motion, each word has its importance. Okay, and the second point is FBD, that is free body diagram. Okay, this free body diagram. So you need to solve. So if it is in rest, then that will be summation of fx is equal to 0, and summation of fy, force in y direction, should be 0. So these are the two things that you need to follow. Okay, so let's make FBD. So that is really important. Okay, so this is your body, this is 10 Newton acting. Okay, so and you know the weight will be acting always downward. So this is the basic thing that you know already. So what you don't know, the direction of the friction. So I said that resist the relative motion. Okay, so means block wants to go downward, so friction will say, hey man, you cannot go downward because I will oppose your relative motion. So friction will act upwards, and there is a contact between these two surfaces, and then there is a contact between body and the surface, there will be normal force. Okay, so similarly, according to the Newton third law, there is equal and opposite reaction. Okay, you know there is equal and opposite reaction. So you know all these things. So this is the basic one. If you have any doubt regarding this, you can ask me. Okay, so now you need to find the weight of the block. So we will apply FBD. Okay, so let's write, that is summation of fx, or it will be fx. And for the sake of the simple and very basic approach, we say that upward is positive and downward is negative. Similarly, this word is positive and leftward is negative. That is basic one. Okay, so in this question that is not very significant, but yeah, you need to know that. Okay, so I will apply the summation of fx, this one I will apply. So that will be plus 10 minus n is equal to 0. So you will get n is equal to 10. Okay, now you know n is equal to 10. You need to find what? Weight of the block. Okay, so let's see how will you find weight of the block. Okay, so now you have, okay, now you have summation of x, and what will be fy. So let's make again to just okay, that will be weight, that will be f, and that is n. Okay, so this was the force. I will rub here, let me rub this one. Okay, okay, this here it is acting. Okay, so this is 10. So you will balance, means this will come plus f minus w is equal to 0, that will become f is equal to w. Okay, so now you have f is equal to w, and you know w is equal to mu n. You will put f. So here you know the friction. I hope you know the f is equal to mu n, where n is the normal force. So you will put point 0.2, and you will put n is equal to 10, and you will get 2 Newton. So it is asked weight. Remember that it is asked weight. When it is asked mass, you will say mg is equal to 2 Newton, and you can get mass. Okay. So I hope you know the process. You know the application of friction. You know the making FBD, and you can simply solve. Only two basic things is needed. First, information of friction force, and the second, that is FBD. So let's do the second one. That is, marble of mass 2 kg is lying on ice with given a velocity of 6 meter per second is stopped by friction in 10 seconds, the coefficient of the friction. So we will write the the given, what's given to in this question. Given, okay, mass is given 2 kg. Okay, so now you have initial velocity is given 6 meter per second, and it is said stopped, means final velocity is 0, and the final time is 10 seconds. This is information that is given. So now we will make scenario what is happening here. Okay, let's make it. Okay, you have block. Okay, so this is block. Let's say it is stopping here itself. Okay, okay, it is stopping here, and now you have time at t is equal to 0. You have time is equal to 10 second. Okay, now you have some initial velocity that is given, and you have final velocity that is 0. Okay, so from this thing, do you get to know something about, you have u v a plus at something like that? Yeah, I know the first point, that is v is equal to u plus at. And what is second point, that is fbd. I can make that as well as Newton second law, NSL, that is said F net is equal to MA. Okay, MA. Okay, so you know that. I'll write here MA. Okay, so you know that NSL, and you know that this thing. Okay, so now you know this thing, F net is equal to MA, and you know FBD and SL, you know that. So now how will you solve that? So now I will see that. So first you can calculate acceleration, and apply FBD. Oh, first let's make FBD. Okay, what FBD says that if this is going this way, let's move. No, you can't go, man. So this is this one, and weight is acting downward. Okay, weight is acting downward, and the normal, this is like this one I am making here. Okay, so you have not normal. And so, and the f net, what is here f net? So you will see this is balance, upward is balance, but motion is this word. Okay, this up vertical is balance, horizontal we see there is motion. Okay, so we'll like f net. So there is simply f net ma. So we'll put ma. Okay, what is f will become mu n. Okay, n m a. I will put mu mg, mu m. Okay, mu mg, that is ma. So we'll cancel out mm. Acceleration become a mu g. That implies mu is equal to a by g. Okay, so if you know a, you mean you know mu. Simple as that. Okay, so let's these things. Okay, so from like we saw that v is equal to u plus at, from where I can get acceleration. V was 0, u is 6, plus a, t is 10 second. Acceleration will be minus 0.06.
so we don't bother about the direction, that is direction. Wait, this is 0.6. Okay, so let me write this one. Okay, let me write the correct one, that will be zero point 0.6. Okay, acceleration will be your 0 0.6. I hope you can see that how it is coming. So it will come 0 0.6. So you don't need to bother about the sign, but you can put here sign. It will come minus 0.06. Okay, now you have 0.6 meter per second square, and acceleration I solved mu by g. No, that was mu was, what was mu? Mu was, you can see that what you got. Okay, so let us see that what a is mu by g. So we'll write those. A is equal to mu by g. So we need to find a is equal to mu by g, and what you have found mu a g. Wait, let me see that what was there. A is equal, mu is equal to a by g. Okay, so it's simple. So mu is equal to a by g. So we'll write mu is equal to a by g, and a is, you need to see only magnitude, so you'll 0.6 and you'll put 0.6 and you'll put 10. So you'll get mu is equal to 0.06. So now you have the final one. So the answer is mu is equal